Okay, we are at Q2, week 9, day 4. Find the quotient. Okay, so we're going to go ahead and divide 38 into 24,358. I always like to put some zeros just in case. All right, so let's think about this. Does 38 go into 2? Definitely not. How about 38 going into 24? Definitely doesn't go into 24. Does 38 go into 243? I would say probably about 6 times. Let's try that. 6 times 8 is 48. 6 times 3 is 18. 18 plus 4 is 22. So we're going to subtract that. All right, can't take 8 away from 3, so we're going to have to borrow from that 4 and make it a 3. Okay, so 13 minus 8 is 5. 3 minus 2 is 1. 2 minus 2 is 0. Okay, so we have 15. We're going to have to bring down this 5. How many times does 38 go into 155? I'm going to say probably, I don't know, 4 times. Let's go with 4. 8 times 4 is 32. 4 times 3 is 12. Plus 3 more is 15. 5 minus 2 is 3. And then 5 minus 0 is 0. And 1 minus 1 is 1. So we're down to 38. Ah, perfect. How many times does 38 go into 38? 1 time. All right, we didn't need any of the zeros. So the answer is 641. That's how we find that quotient. Okay, we're going to find the quotient again. Okay, this time we have decimals, and we cannot have decimals in our divisor. Okay, so this 0.09 is just going to have to be 9 by multiplying it by 100. So we're going to have to do the same thing to the other side. So we're going to now divide 9 into 588.6. And again, adding zeros. Anytime I do long division, I do that just for the heck of it. All right, so how many times does 9 go into 5? It doesn't. How many times does 9 go into 58? That goes in 6 times, because 6 times 9 is 54. I'm going to subtract that. 8 minus 4 is 4. Bring down the 8. Okay, so how many times does 9 go into 48? 5 times, because 9 times 5 is 45. Okay, 8 minus 5 is 3. Bring down the 6. How many times does 9 go into 36? Exactly 4 times, because 9 times 4 is 36. No remainder. We're done with that. We just have to bring the decimal up. So the answer is 65.4. Okay, the big key about this one is making sure that you are taking care of these decimals so you can do the long division problem. All right, that's the answer to that one. Isaac has 21 green marbles and 7 blue marbles. Okay, if he wants to place them in identical groups without any marbles left over, what is the greatest number of groups Isaac can make? Okay, well, I found all the factors of 21 and 7. It turns out that the largest number that will go into both 21 and 7 is 7. All right, so what it comes down to is they can do 7 groups. That is our answer. Okay, and each group, because 7 goes into 21 3 times, it's going to be 3 green. And 7 goes into 7 once, so 1 blue. So each group, okay, you're going to have 7 groups, and each group is going to have 3 green marbles and 1 blue marble, because 7 goes into 21 3 times, 7 goes into 7 1 time. So there you go. So you're going to have 4 marbles in each group, 3 green, 1 blue, 7 different groups. There you go. All right, 80% of the 6th graders at Harrison Middle are going on a field trip to the museum. There are a total of 685 students in this 6th grade. Okay, so there's a total of 685 students. Not 100% of them are going. Only 80% are going. How many students are going on the field trip? Okay, guys, remember 80% is the same as 80 over 100. And that is also the same as 0.8 or 0.80 because 80 divided by 100 is that. So again, all three of these are the same thing. So we can utilize one of these to kind of help us get the answer pretty easily. We would just take the total number of students, 685, and then we would multiply that by 0.80 or 80%. Okay? At that point, we would just have 0, 0, 0 for the first one. We really didn't have to do that one, but just wanted to show it as 80%. Then the next one, we have 8 times 5, which is 40. 8 times 8, which is 64, plus 4 more, which is 68. And then 8 times 6 is 48. And 48 plus 6 is 54. Okay, so now we can go ahead and just add these. We have a 0 and a 0 and an 8 and a 4 and a 5. But how many decimals do we have to move over? 1, 2 places. So here's our answer. So 548 students are going to the museum, right? So 80% of 685 is 548 students, because we just did the decimal of 80%, which is 0.80 times the total number of students. That's how we get that answer. Okay, this says simplify the expression 36 plus 18x. And then we're going to know the coefficient and the constant. Actually, the interesting thing about this one is we have a lot of numbers we can divide into both 36 and 18, and we don't have to use the largest one. Okay, so we have a few different possibilities here. We can even divide them both by 18 if we wanted to. So, I don't know, we have 2, 3, 6, and 18. They're all going to go into 36 and 18 evenly, and all of them would end up simplifying it. The only one that wouldn't simplify it is if we divided them both by 1, because it would just stay the same. So, I don't know, let's just choose 6. All right, let's just use that one. So we have 6 on the outside of the parentheses. How many times does 6 go into 36? Well, it goes into it 6 times. And then plus, how many times does 6 go into 18? 3 times. So we have that. Did we simplify it? Yeah. And we could have actually done a few different ones. But since this is the way that we did it, we're going to use this information to answer these two questions down here. It says, what is the coefficient of x? And remember, the coefficient is the number next to the letter x. And since we use this approach, the coefficient would be 3. Okay, and then what would the constant be in this? Well, actually there's 2 constants, and they're both the same. So the constant is 6. So there we go. The coefficient is 3 because it's right there next to the variable. The constant is 6 because it's just a number by itself without any variable. All right, this problem says, are the two expressions equivalent when x equals 3? So if we put 3 in for x, are we going to get the same answer is what they're kind of asking for that one. So let's look at it. Okay, so it says, are the two expressions equivalent when x equals 3? Okay, so basically if we put in 3 for x, are they going to come up with the same answer? All right, well, this one here looks pretty simple already, so let's not worry about that one. Let's do this one and distribute the 5 to everything inside here. Okay, so 5 times 2 is 10, so we have 10x. And then we have 5 times 8, which is 40, so we're going to have plus 40. Okay, so the 40s are the same, and then whatever the 3 is, we put that in for x. Okay, that's going to be 2 different numbers. 8 times 3 is 24. 10 times 3, excuse me, is 30. So, and they're both going to be added to the same number, which is 40. So are the two expressions equivalent when x equals 3? The answer would be no. Okay, we can see that they're clearly not going to be the same answer. If you put in a number for X, they're not going to be the same answer. They're going to be two different answers. Okay, the United States won 63 gold medals at the Olympics. 12 of those were swimming medals. Write an equation to express how many medals were won in sports other than swimming. Okay, so let's look and see. We know that 63 total medals, gold medals, okay, were won by the United States. Okay, and we know that 12 of them were won in swimming. So 12 plus basically all the rest of the medals would give us a total of 63. So we can put M for medals maybe. So 12 were in swimming, and then plus M, all the rest of the medals, would equal 63. So it says write an equation to express how many medals. Here's our equation. Okay, 12 plus M equals 63. So if we were to actually solve for that, we would just take 63 minus 12, and we would know that M is 51 medals. Okay, but they weren't even asking for that. They were just wanting to know what would the equation be. So there it is. 12 plus M equals 63. In order to stay healthy, Kevin's doctor says he should try to consume at most 2,000 calories a day. Okay, so what does that mean? It says at most 2,000 calories a day. Well, that means they want Kevin to do 2,000 calories or less, right? They don't want to do 2,000 calories or more, 2,000 calories or less. It says write an inequality to show the amount of calories Kevin should consume. All right, so once again, 2,000, if we were to put this on a number line, we would put the 2,000 and we put a dot, right? And then we put an X or an N or something like that over here. And this number represents the number of calories Kevin's allowed to have in a day. And remember, they want him to have 2,000 calories, so he can have exactly 2,000 calories, which means we can put that little equal sign there, or less than. So this number has to be less than 2,000 calories. All right, so that's basically it right there. We have X is less than or equal to 2,000, and that would represent the number of calories he can consume in one day. So there we go. Ruth is making lemonade. For 1 cup of water, she uses 3 lemons. For 2 cups, she uses 6 lemons. Okay, so if this pattern continues, how many lemons will she need for 10 cups of water? Well, we can just keep going. 3 and 9, 4 and 12, 5 and 15. Okay, but now we need to jump to 10. So we have a few different options now. We can actually do this. We can take 1 times 10 and then 3 times 10. Or we can do 2 times 5 and get us 10 and do 6 times 5. Or we can do 3 and 9. No, can't really do that one. 4 and 12 doesn't work. But 5, we can use that. 5 times 2 would give us 10. And 15 times 2 is 30. So there's a few different ways we could have done this. Okay, but we would definitely know that we need, it says we're going to need 30 lemons, okay, for 10 cups of lemonade. So that's how we find that answer.